Hello everyone. We are glad to be the part of a Gemma 3N Impact Challenge. We will be demonstrating our solution MediGemm for both the overall track and the Google AI Edge track. My name is Samarpita Bhaumik and my fellow teammate is Sunnidhya Roy. So, the problem statement is that the people in the remote areas face significant health challenges due to the lack of immediate medical support. Without internet access and with doctors or hospitals located far away, critical situations like snake bites, accidents, complications during pregnancy, etc., can become fatal. Common illness like coughs and colds are also often rejected, leading to worsening health conditions. The delay in receiving timely medical attention is a major cause of preventable deaths. So, the solution is that our app provides a crucial lifeline for these communities. It operates entirely offline, offering immediate step by step guidance for a range of medical emergencies and common ailments. This includes first aid instructions for snakes and insect bites, accidents, pregnancy related issues, and etc. The app also provides preliminary advice for illness like coughs and colds. By delivering essential, easy to understand health information in local languages directly to users' phone, we empower individuals to take the right actions immediately, helping to bridge the gap in healthcare access and save lives.
Hi everyone, my name is Sunnidhya Roy. I'll be demonstrating how to do the diagnosis based on symptoms and optional images which the patient or the user will be entering. So I'll give you a walk through of our app, also some pointers on how to install the app and what are the steps which are involved. So basically, first, as usual, you have to install the APK on your Android device. And on the first launch, the model as in the Gemma model and the Universal Sentence Encoder, these two models will be copied to the local storage. So the Gemma model is basically will be used for the inference part, and the Universal Sentence Encoder, we are using it for our RAG pipeline. How it is used? So basically, we have formed some documents of common diseases, and like we have included step by step, procedures, like what are the treatments, what are the preventive measures, at-home remedies, what are some other diseases which could be related to this, and also we have formed such documents for some common diseases in both English and Bengali. Why Bengali? Because we want to showcase the multilingual capability of the model. So that's why we are also using the Universal Sentence Encoder application, the model, Universal Sentence Encoder model, and it will be basically used for computing the embeddings for each of the documents. And when the user gives in their symptoms in the describe your symptoms part, you will basically like it will form the embeddings out of that symptom and try to find the best match from the list of documents using cosine similarity. And once it has extracted out relevant diseases, it will append it to the system prompt, the symptoms or the user prompt, and this additional context. Also, like we have aligned the model in such a way that if suppose the diseases which have been extracted are not related to what the user has given, like if Gemma, like while inferencing it finds out, so it will entirely neglect the relevant diseases part of the prompt, and give it will give the diagnosis of the symptoms from its entire from its internal learning, from its whatever the model has learned from the training pipeline. So, and also, like the model is aligned to answer only in medical domain. So if you ask it anything outside medical domain, it will just say you it's not an expertise in that. So once this is done, the app is now ready. So for the first launch, it will take some time to set up this entire thing. And once it is done, the app is now ready for diagnosis. Going forward, from the next step onward, next launch onwards, you don't need to wait for so long. It will be done instantly, as I will show you in the demo. Our app for now supports text, image, text plus image as inputs. You just need to enter your symptoms over here and then select an optional image and then just click on diagnose and just sit back and let the AI figure out how to deal with the disease which you are having. So I'll be demonstrating the the entire walkthrough of the application which we have built. So yeah, so this is the application which we have. Okay. So this is the application which we have. So first of all, we are installing the application. This is an entire walkthrough of the of our application. So yeah, now we install the app. Um, yeah, let the app install. So yeah, the app is installed. Now we open the app. So MediGemm AI Diagnosis, that's the name of our application. And now you can see the model has been copied to the internal storage, the zip file, and now it's getting decompressed so that we can then load the model for inference. Along with that, we will also load the Universal Sentence Encoder, as I have told you previously, for computing the embeddings for the documents, and later on to compute the embedding of the user symptoms in the user prompt. So yeah, the first time it takes a bit of time, so let's wait for it. Um, yeah. So the model is being decompressed. Let's see. Well, it should be done soon. So it's a huge model, so almost 2.5 GB, 3 GB size. So yeah, like it will take some time. So yeah, I can see the model has been loaded. Now it's preparing the model for inference. So the model and everything is loaded. Now I'll just close the application. I'll relaunch the application. As you can see, it loads instantly from storage. Next time onwards, it doesn't take time. So this is the first symptom which I'm giving. So I have cough and cold. So what to do? And I click on diagnose. Yeah. So I already have a document regarding cough and cold, flu, and everything. So basically, like in the backend, it will basically this entire I have cough and cold, what to do will be converted into an embedding, and it will try to search among the documents which is the relevant one, and it will pull out the documents which are related to cough and cold, and then along with system prompt, this user prompt, this the query, the symptoms which the user has given, along with those relevant documents containing the diseases, that will be sent to the gemma model for inference. And so this analysis is it's taking time. It is taking a bit of time because like we are using our backend as CPU, and as a result, it is it's computing it slowly. But yeah, let's wait for some time. Hopefully, it will be done. Yeah, so we got the response, and as you can see, so we got some at home remedies which we can go ahead with, and like other necessary precautions which the person can take. So this is for this thing. Now I switched off the internet to show you the offline capability of the model. I'll select an image. So this is my hand. I got a cut in my hand recently. So I'll just write I have cut in my hand. I've cut my hand and it is itching and burning. Yeah, so it is itching and burning. Yeah, so what to do? So I'll just click on diagnose. So this is basically showing the multimodal capability of the model, and that too in an offline setting. I've turned off the internet, and yeah, so the thing is that initially when we were doing the LLM inference, it was taking a lot of time, almost taking 10-12 minutes of time. Then we tuned some of the hyperparameters, and then we got a speed up. Like from 10 minutes, it dropped to 2 to 3 minutes, like even lesser than that, 1 to 2 minutes time it takes to analyze and give you the content. But yeah, um, because this is an evolving process. The entire the model we tried to quantize it using we tried to quantize it to a smaller size using LoRa and everything, but unfortunately, like it was we were not successful in that, so we couldn't go ahead with it. But yeah, that process is that work is still in progress. So once we are able to do that, so the inference time will drastically reduce. So as you can see, I got the response, and again it has given some at-home remedies, some precautions which is to be taken, and some other important informations. So yeah, so this basically demonstrates the multimodal capability of the model. Um, so like one thing what we tried out was to quantize the model uh, to so as to get get a smaller model with like similar efficiency, but yeah, we were not successful. But yeah, the work is in progress, and once we get it for CPU, because like we have to cater to all we have to cater to all the different kinds of devices, the low powered ones as well as the high powered ones. So the low powered ones should also be able to give inferences within a short period of time. So yeah, the work is in progress. So yeah, hopefully we'll be able to boost up the inference time. So yeah. So now coming to the next part. So this basically this query, well, I'm giving it in Bengali, that is my native language, to show the multilingual capability of the model. So what I'm writing is আমার পেট খারাপ হয়েছে, ভীষণ পেটে ব্যথা করছে. What it means that I am having stomach pain. My stomach is upset. What should I do? So we'll give this input to the model. So now I have some set of documents in Bengali as well, which basically describes the diseases, the different kinds of diseases, common diseases which one can have. So like the same rack pipeline and everything will go on. It will try to retrieve the relevant diseases, and then uh, like uh, try to come up with an inference. So mind you, there are two things. If the relevant diseases are not related to the symptoms which the user has given, the gemma model is instructed and aligned to respond with its own learning and not use the additional context information. Also, like in the next part, I'll explain that it's aligned to not answer anything outside the medical domain. So yeah, let's wait for this thing to complete. So um, okay, hopefully it will be done soon. Yeah. So this basically demonstrates like we basically demonstrate the yeah. So as you can see, we got the answer in Bengali, which is my native language, and it has again basically given the different at-home remedies, the different other diseases which could be possible, and all. So yeah, the last prompt which we will be trying out will be like a prompt which is entirely unrelated to medical domain. So what is the highest mountain range? Let's diagnose that. So so we have aligned the model so that it doesn't like answer anything outside the medical domain. Yeah, so as you can see, I'm sorry, I cannot answer this question. It is outside my domain of expertise. So yeah, so that concludes my walkthrough of the entire application. Walkthrough of the entire application. So once this is so basically you get a brief overview of how the application will be helpful in an offline setting uh, using for remote areas where medical facilities is very rare to find. Like people die of basic ailments which like they can easily get cured from. So this will help a lot of audience because to be honest, people living in remote areas are much more compared to the people living in the urban areas. The rural area people are more for different countries altogether. And uh, the multimodal capability of the model, along with its offline setting, it gives a huge boost to like AI diagnosis of various diseases, like basic diseases to critical diseases. And the multilingual support is another like is another like is another feature which will help a lot because not everybody can read English. So in India alone, like we have so many languages. So someone may be speaking in Bengali, some in Hindi, some in Odia, some in Marathi, some in Kannada. So yeah, the this model will be this application will be able to take in input in different languages as well and give proper remedy for it. So yeah, so that concludes my demonstration. Yeah.
Hope you like the walkthrough of our app that my fellow teammate Sunnidhya just gave. So, talking about the future scope, that this is a proof of concept and we are committed to make continuous improvements. Our future effort will focus on optimizing the app's performance for faster responses and expanding compatibility to support the older Android versions. We are also exploring ways to enhance CPU efficiency while running the model to ensure the app runs seamlessly on a wider range of devices. We are also trying to build a more quantized version of the model to make it run faster on a CPU with similar efficiency. Also, we are looking to integrate RL pipeline through reward functions to align the model more on medical domain using feedback and prompt optimization. Thank you.